AI engineering is hard until you learn this. The thing is, you're not bad at AI engineering. You're just bad at the method you're trying to learn it. So the thing is, people right now are going on learning about the transformer architecture, LLMs, how to do chat prompts, and that's fine if you just do that by itself, but that's more of like content cosplay and not necessarily learning, right? The real shift is actually doing real AI work. The thing is about this, why it feels impossible is because you're just doing examples and hoping it will work out. I want to show you how to get out of that loop and actually make yourself employable, because there's a lot of AI jobs out there, but you have to be able to showcase to be able to get these people to look at you, right? So at the end of this video, you're going to go from not just reading papers, but actually becoming a real AI engineer and solving real problems. Here's the uncomfortable truth. You're serving the wrong customer. By that, what I mean is, right now you're trying to serve yourself or your own ego, trying to feel smart because you're trying to learn every single hot topic or hot trend that's happening right now in AI. Literally every week, there's something new that comes out that beats the last thing that came out. And the thing about that is kind of fake progress, because just because you're going up and you're up to date with the latest news and you're seeing the latest trend that everyone's doing, and then you're putting it out there, or you're basically learning about it, right? And not actually putting anything out there. You're optimizing knowing stuff and not actually doing anything or solving any real problems. And the bottom line is, tech rewards solvers, people who are actually doing something. It doesn't reward people who know anything. It's kind of like unrealized potential is useless, right? You have to be able to put energy behind it, have kinetic, or get an output, something tangible out of it, right? Even if someone knows a lot more than you do, and I've seen this a lot, where there's people who know a lot more than I do. I've worked with a lot of PhD people in this stuff, in this space, and they haven't done a single thing, mainly because they're afraid, because you actually have to put yourself on the line out there by committing, okay, I'm going to get this job done and have an actual tangible output out of this, right? A KPI, a key performance indicator, saying that there's an actual tangible output out of it, right? Whereas knowing something in theory, you could talk about, you sound great. It's kind of like being a critic. You could say anything without any accountability. So I worked with PhDs, but they only have to do is prove theories. And it's important. Don't get me wrong. I don't want to put them down. It's just that it's a different space, right? They're hired to do researchers and do blue sky things. Whereas if you want to get paid, companies get paid to get results. And they want to see that, not just because you know how to do something, they want to see it being done. One thing I want to warn you about right now that I see a lot of people in is the AI trap. And what that is that the AI trap, it looks very helpful. And one thing I'm talking about in particular is vibe coding. Yes, vibe coding actually is good. It gets you results. But why I want to say it's an AI trap is if you are trying to use that and try to say that you're trying to get a job with that, for example, or you try to say you're an expert at it, because that's where the trap comes in, because you'll feel unstoppable. Because you could say what you feel, or kind of like declarative, you know what you want as an end result, and you say what it is, and you see it manifest in front of you, and you're like, that's great. But here's the thing. If you don't understand coding, if you don't understand the architecture, the frameworks, or the reasoning behind it, don't understand the code, you can't debug it, you cannot explain it, you're not be able to optimize it, and you can't adapt it. So when you're in a real production, or you're working with a real client or for a company, and you're trying to solve a real problem, and the first version or cannot get it to work exactly how you want it to work, or it's expected to work for the client or the customer or for the employer, it's up to you to go and fix it. And if you can't, then you get exposed, and it's even worse, because then you'll probably lose your job, you lose your reputation, and things like that. I'll give you an example of this. It's not actually in the space of AI, but it was my background. I worked in 3D graphics. I still do, now incorporating AI with it, VFX, AAA games and whatnot. And I had one person that wanted to move up in their career and asked me how they could learn. They wanted to learn pretty much like visual effects, like particle effects and things like that. And one of the books, I told them that it's an excellent book. I believe if you're doing 3D space, I know this is not a 3D channel and all that, but if you're doing 3D space, I think one of the best books you could read, even if it's not your 3D software, is Deconstructing the Elements by Pete Draper. It actually shows you step by step how to do it, explain it, and you learn a lot about the software and how it's broken down. the thing is about it, he also shows you the end result, right? So I told him about that. I said, learn about it, go through all the examples of the book, understand it, and then adapt it and make it your own afterwards. So he said, thank you, that's great. And then like about a month later, he quit his job because he got another job at another company. What I found out afterwards, he went and then afterwards he was let go after like 4 days because he didn't actually know what he was doing. What I found out afterwards is he didn't actually do the examples in the book. He took the scenes and results, re-rendered them, basically took the end results because they gave it to you, showed it to people, and say, oh, that's great. But then when it came time to go and actually work, he couldn't actually do it. So this is why I find it's very important is that vibe coding might get you the end result that you're looking for, but if you don't understand right here what you're doing, you're not able to debug, explain, optimize, adapt at all. You won't be able to actually maintain a job. So it's very important to actually understand what's happening, right? It's not leverage in this case, right? Like learning how to vibe code, learning how to use that is not leverage. It's right now a dependency basically with a lipstick in it. Now, if you know what you're doing, it is helpful. For example, if you are more like a senior person of a project, will probably do more of the architecture or orchestrate how things will get done. And then you're basically telling your team what needs to be done and know what to expect. It's more kind of like product management at that point, right? At that point, doing something like vibe coding might help because you're guiding it, you know what to expect, you know how to fix it, and you already understand how to debug it, explain it, optimize, adapt it for this scenario. But that comes with experience, that comes with understanding, right? So that's another thing. Oh, I also mentioned here what happens when ChatGPT servers go down. I've seen an example of that where some people are in the AI trap here and they think they know AI but they're relying on ChatGPT. So as soon as like the servers is down, they cannot do their work because they can't actually do this without it, right? So the thing is, yes, it's helpful understanding these things, but you have to understand it. So you have to be able to do it without these assistants. It's kind of like learning mathematics, learning how to divide, add, subtract, long division, do it by hand. In real life, nobody ever does this. You use a calculator, right? But you're not taught with just a calculator. You're taught how to actually do it so you understand what's happening. And then you use these tools to enhance your workflow. You don't depend on it. That's how you actually become obsolete. Because if you don't understand what's happening, you're going to be replaced by someone who does. Another thing I would like to talk about is the broken foundation. And this is in the context of if you're trying to actually get a job as an AI engineer and get a salary of 200K plus that you're seeing that people are getting on LinkedIn and things like that, is that the way people are learning now is kind of what was needed at least 10 years ago, and that's to become research ready. And you didn't really have choice back then because you had to become an ML engineer, basically machine learning engineer or deep learning. Basically, deep learning is machine learning or neural networks, but if you have more than 2 layers, they just coined it as deep learning. It's more of a trending name. It's neural networks basically with that, right? And the thing is, you're not necessarily becoming production ready. And the thing is about that is that it's a difference, right? If you're becoming a researcher, you're more academia side, you are looking at studying a lot more of the math, the calculus, like how to calculate the gradients for the loss of things like that, for the back propagations, statistics, linear algebra, because you're dealing with a lot of the weights and you're multiplying. That's kind of like what you're doing with in-game and real-time engines as well. That's why GPUs were very helpful. They're analogous to how machine learning worked. But again, all this stuff is very important if you're going to look under the hood and you're going to develop as a researcher. Blue Sky, that is a very different lifestyle. It's they are there to have blue sky ideas in the future, and you have to prove it. It's very competitive. You have to keep innovating and keep beating the last state of the art with it, which is very important. But that's not the same thing as if you're trying to get something in production and something out there, right? So if you're going to academia and you're trying to go to be research ready, school is more of a game where you're trying to get grades as opposed to shipping. Like the industries I'm from and all the jobs that my careers I've been from is very competitive, and it's only one metric: did it work or not? From the movies and the game industry, the VFX, I worked on Avatar, I worked on like How to Have the Chance of Meatballs and Teenage Mutant Ninja Turtles Mutant Mayhem. I was a freaking CG supervisor. The poster's already made, the trailers are already made, the game before the game even exists or the concept even exists, right? So the date's already made, you have to ship it. So your only metric is, did it work or not? It's not the same thing. Nobody cares if you got good grades or not. And I taught in schools for 3 years in person. I still teach. I have online courses and I still have one-on-ones with clients and whatnot. But in terms of actual formal teaching to give people a career, I've done that for 3 years. And I can definitely tell you school is built for grades. And it's interesting when students come up to me and they're arguing for grades. And in my mind, I would tell them as well, is like, I know you're in school and you're worried about that, but in real life, it doesn't matter. When you go to a job, they're going to look at it and I'm going to say, can you do this or not? Maybe when you first come out of school, because you have no actual reference in terms of you never had done any real world experience to see that you could actually deliver something, the grades is probably the only possible indicator, and even that is not even perfect. But after that, it's once you got your first job, nobody really cares anymore, right? Everyone looks, can you actually do the job? Can you ship? Can you deliver? That's what's matter. That's what the industry is built on. Just imagine, I was trying to explain this to people. As you're someone who's trying to get a job, of course, people are like, why don't they hire me, right? But I said, like, change your point of view, put yourself in their shoes. Like, if you had your own company and why you're hiring someone, because you need something to get done. And or not even that, let's say you have your own place where you live right now, and you have a leaky pipe, right? And the pipe burst. When you're trying to call a plumber, you're not trying to see if they had good grades. You're trying to find someone who actually gets the job done. That's what a company is doing. They're looking for someone who can actually ship and deliver what they need to do. You have to be able to prove that. And just to give you some perspective on this, I'll just clear this so you could actually undo that. Clear this so you could actually see, or undo that so you could see this part. I personally do have a computer science degree in machine that basically specializes in machine learning and AI, and I graduated with honors with that. But one thing I want to mention about that is that I did that after I worked for a few years in doing AI for companies and delivering it. And the reason why I got it at the time was I started my AI company, and when I started working with investors, part of that is that the believability and your authority in the space to see if they actually know what you're talking about, right? So I made sure I got a degree for that. But in the end, it didn't really matter as much, because at the end of the day, when they actually look for traction, they want to know, okay, are customers actually buying your product, right? And is your product actually doing what it says it does? Basically, what are the results, right? Shipping, right? So if I'm showing the product does what it says it does, is bringing customers, is actually delivering value, right? There's an ROI, there's a return on investment on it. That proves what I need to do. So I just want to mention that part, that school is mainly a grading system, is more for a game, and that academia is one thing. But if you're going to go work in the world, you want to actually ship. You want to be shipping something, prove that you can actually get something done, right? And I want to mention about this part here is that what I've noticed, that I mentioned this earlier in the video, that people will consume and start learning about a lot of things. So they feel good because they know knowledge. But if there's a difference between doing that and actually going out and doing work, because now when you're actually trying to do something, there's accountability. Like, did it work or not? It's like if you're trying to go to the gym, for example, right? And you let people know beforehand. Some people might be afraid of that because it's a long process. If for certain people, it might be a long process before they see results. And if they give up halfway, people will be like, okay, what happened? Which I understand, right? And that's the problem with the accountability, is that if you say you're going to do something, you have to stick through it until the end, until you get a result. And going and doing just like YouTube videos and just watching and learning about certain things, you feel like, okay, you're learning something, but you don't have to account for anything. You don't have to show anything at the end. Whereas if you say, okay, the metric is I have to build this thing that actually does what I wanted to do, specifically answering a solution or answering a problem, being a solution for something in my space, the accountability is, does it work or not, like in real life. And if you want to get a job, you have to have accountability. by doing projects, seeing it through, making sure it actually delivers on it. And one way to help with that is actually getting other people who are on board with you that are going towards the same thing and going to hold you accountable, because it's going to say, hey, okay, where are you right now with this? Let's see the results. And it could also help you work out what you need to do next to get to your results. I want to explain why this matters in terms of if you want to be an AI engineer and actually get paid by companies to deliver. Your lifetime value as an AI engineer is actually from shipping, meaning giving end-to-end results from the concept to completion and actually having a result, having an impact where you build products that actually make or save them money, right? Or you deploy that's the main thing here, working models here, not just theory, for productions that actually use and actually has an impact on it. And you're creating AI systems that scale, meaning that once you make it, you can make it bigger and bigger. And it's not a one-shot deal. It actually gives back more than they actually put in. Or as well, if you could actually launch AI startups, which I've done, right? So if you have an idea and you don't necessarily want to go work for another company, you could do it for yourself. And the other thing about this, why it matters, is the metric is the ROI, the return on investment, not the accuracy. Again, accuracy, what I mean by that is if you're going the researcher route, you want to actually build machine learning models and research and make something better than the transformer model, and you have lofty dreams to go and shake up the world and become a name in the academic world, that is what you're doing in that space, is that you're reading papers. There's a metric of the state of the art of how good on these benchmarks these models perform, and you're trying to do better. That's your job the whole time, and trying to do more blue sky things, meaning more out of the box thinking that in 5 years the world change of this, right? That's again a type of thing is very important. That's when we need to move forward. But I'm talking about becoming an AI engineer. And if you're doing that as an AI engineer, your metric here is to ship actual products. And if you're not, then you're just interested in AI engineering and you're just reading about it and just like to know about it, but you're not necessarily want to go into it, right? So the thing is about that, if you're actually trying to go into it, you don't want to be doing the wrong learning and basically have an infinite delayed payback on that. And what I mean by that is that you're putting a lot of work, you're reading more papers, you're doing more tutorials, but you're not actually doing anything to get results, right? So you're getting absolutely no results, right? I mean you have to go and try to solve a problem, actually ship something, actually deploy some type of product, whether you have a client or not, make up an actual product that you would like to see, get it done, and that's your demo. That is your portfolio piece. That's what you're going to showcase, and that's what you market, so companies will hire. Or else you're just permanently interested in AI, and what will happen is you're just going to keep learning without actually doing anything, and you're going to burn out and give up, which I see a lot of people do, because they're like, I'm doing all this work, but I'm not seeing any results. And because you have to do the right things, you have to do the actions that generates those results, right? So if you're not applying to companies, for example, how do you expect any companies to respond back to you? But even if you are applying for the companies, if you're not doing the right things, we're actually building a product that type of company is looking for, or you could adapt it to see how they could improve their bottom line, they're not going to get back to you. I'll give you a story that he's seen on Texas Ranger, which was Chuck Norris's TV show, and he gave a story in there where he mentioned that is an analogy, I guess. They had this person who wanted to win the lottery, so he, asked the higher powers, like, could you, make me win the lottery? And they prayed every day, and every single day was diligent and asked and prayed for it. After 10 years, he never won the lottery, and it was mad and said, like, I did everything you want, but you never made me win the lottery. And the thing is, after 10 years, that person never once bought a lottery ticket. And the moral of the story is that you could do what you think is right, read more papers, in this case, do more tutorials. But if you're not actually going out there and basically doing what's needed to get the job done, like actually applying for a company, actually building a product that works end to end, that saves money or show an ROI that a company's interested in, you're not going to see any results. So you're just going to be spinning your wheels. You're going to be working hard, yes, but you're not going to see a return on investment. You're just going to be burning yourself out, as you see here. And that's the thing. You want to work smarter. You could, if you focus on the right things, and even if you don't feel as prepared or as knowledgeable as you feel now by reading all these papers and being abreast of all the things that are happening, if you're actually able to deliver something, you're going to be way more valuable and way more attractive to companies. Now, compounding damage, and what I mean by that, compounding self-trust, or more, I would say, is more compounding self-doubt. And what I mean by that is that I mentioned this in another video, where unless you have, at least a lot of people, unless you have a fire that's lit under you, most people are not motivated to do something, because once it gets a little tough or inconvenient, or especially if something gets slightly inconvenient, or I have I don't feel like doing something right now, or I have a slight headache, you'll stop what you're doing and relax, and then go sit down and binge watch 5 hours on Netflix or the latest Stranger Things. You have no problem doing that. But when it comes to sitting down and getting some work done that you don't see results right away, it's something that you have to build up. It's kind of like going to the gym. You don't see results right away, but if you do consistently doing the right things, you'll see it. You get exponential results afterwards, or I guess delayed gratification, right? So what happens with compounding self-doubt is things never get done, because as soon as something gets inconvenient, you stop, and it compounds over time to the point where you forget about it. So things never actually gets done. Now, this is where it separates people in the actual industry, or the people who are getting jobs and the ones who are losing out on it, right? Is that if you actually go through work, learn how to do all these things, you start becoming rare, because most people don't do this stuff. And rare people don't get replaced. If you are a dime a dozen, then you're becoming replaceable, right? So one thing that might happen right now is that, okay, well, I might know a little bit of AI prompting or prompt engineering. Okay. And then maybe go one level above, or I know how to use the AI API, OpenAI's API. Fine, but the thing is, everyone could do that right now, right? So you're not rare, and you have to be able to differentiate yourself with it. What companies are looking for is someone's able to diagnose why a model's accuracy's dropped in production, right? Which is what actually happens, or they're expecting it to get a certain prediction or send a certain output of it, and you're not. So you want to know why. And then you want to optimize inference speed. Basically, inference is for when a model is actually making predictions or giving the inputs, is producing the output for it. And if it's not an inference, it's training, it's learning, right? So when you want it to be as fast as possible without losing quality, and also as light as possible, right? If that's possible, making it not as memory intensive. And you want to be able to build data pipelines where you could take in information that's especially unstructured. I'll give a simple example. Like if you're dealing with a lot of business office workers or industries, a lot of it is they have to probably do things that are dealing with dates, like invoices or things like that, right? And dates have there's no standardized way of how you put a date. You could put day, month, year, or month, day, year. Some of them put 2 digits, some of them put 4 digits, some of them actually spell out, let's say Monday. Sometimes they don't even put the day of the week. Sometimes they put MON for it. Sometimes it's capital, sometimes it's not. And also then you have time zones, and sometimes they put the time as well. And then you have the other languages, and they have those words spelled differently. And you have to deal with all these things. So having a data pipeline that could, let's say, take that data, conform it, sanitize it, and then those are all the edge cases. So if you're dealing with another country, it actually clean all that information, and you don't have to. This sounds simple, but it's very tedious, and it's a real problem that a lot of companies dealt with in the past, deal with before, and you spent a lot of hours, and that could be being used for something else, right? And be something that is a lot more productive with the company's time. So you could deal with all these edge cases and make them become basically non-starters or not a problem at all. You're extremely valuable to the company, and then they'll become rare. as opposed to like, hey, I could go in and manually type in all these numbers for you, right? That's very time consuming, is error prone and whatnot, right? And if you're able to do this, and not only that, say you could deploy this and then put it at scale, saying, hey, I could do this. I built it on this local machine, so I could do it on anybody on my computer, but I'm also able to produce this for the company at wide and also ship it as well and make it deployable where you could actually do it for all the different branches for the company. Then the way you design it, because you know how to actually deploy them, right? And you can do it at scale. That is super valuable for companies. Those are the type of things that startups made of because of the impact it could have, right? You want to be able to show, you gotta have proof from actually shipping systems, right? And I know a lot of people, they feel when they're applying for jobs, if they might have like imposter syndrome. That's because they're like, oh, I never done anything before. Well, that's why you want to go and actually do these things on your own. Even if you don't have a job, actually make a model, produce it, put it out there, because confidence comes from competence. So when you've done something before, how confident are you to talk about it? Because you've done it before. You don't have imposter syndrome because you've done it. And that's, by doing it, is the best way for you to showcase your work and to prove and become valuable to companies. Now, I want to talk about the paradigm shift. If you're serious about actually becoming an AI engineer and shifting from whatever your industry is, or actually staying within your industry, but having AI engineering superpowers to take your career to the next level, the main thing I have to say is stop being a passive learner. You have to actually stop being passive about it. Yes, reading and hearing about the news is fine, but you actually have to go out and build something with focus, meaning have something at the end. What happens is when you do that and you actually get deliver on a product, you become important. And especially if you're working at a company right now, and all of a sudden you're able to increase productivity much faster, you become important. And understand this, important people get what they want. I actually worked on the Hunger Games, the first film, where Katniss was speaking with her little sister Prim, and I got that line from there, where Katniss wanted to achieve something. Wanted something. I forgot what it was exactly, but Prim, and he was talking to her little sister, and her sister Prim said, "Well, you're important, right?" He says, "Yeah. Well, important people get what they want. If you want to become important, don't be a passive learner and actually build something with focus, something with value, and you become important, and you get things done more in your way." But it doesn't work unless you actually have a paradigm shift and actually go out and actively work for it, right? And here are the actual steps. Step 1, I recommend highly, do not try to change the world. I know what I mean by that is that I know what sells and what makes the news and what makes headlines is this big new model that could do this great, amazing thing. But you're not, or most likely you're not working at Google or Facebook or Meta or Microsoft, or Nvidia or something like that, or you have unlimited resources and they are willing to spend millions of dollars for you to do computation time to go calculate something, right? So you're not necessarily going to go and discover something that's better than the transformer algorithm or the transformer model right now, right? Most likely. That's what you're trying to do if you're trying to be an AI engineer or you're trying to become important. What you want to do is find one customer and one problem and solve that. Especially if in that industry, if you could find one customer, one problem and prove that it could work, you could find more in that, right? Step 2 of that is choose one stack, like tech stack, or basically one framework or one change of framework or one way of working that works and that you can get your results from end to end, from the beginning, taking information and actually process everything at the end. Get that one stack to work and focus on that and optimize that. No hopping around or like, okay, now this time I'm going to use PyTorch and the next one I'm going to try out TensorFlow, right? This is not experimenting days. You're actually trying to optimize for your own career and actually get results. Work on that. And once you're getting results with that, maybe later in the future, you might add one other thing to see, evaluate if it can make you better or faster. But if you try to go and try to learn everything out there, you're going to be back into what I was mentioning before, the infinite loop, where you're going to keep learning and go down a rabbit hole because literally every week, something new comes out, right? And that's better than the last one in some capacity. But one thing I want to say about that, even though it's quote unquote better, is not necessarily better in your context. For example, I could give you an example of where I have worked on an actual system recently where I know like Minimax or came out and like as a standalone model where you don't necessarily have to go to the internet. You could build it locally on your own machine as long as you have hardware and enough memory to host it, that it's getting performances comparable to like ChatGPT 5 and whatnot. The state of the art, it's very comparable in its range. I think it's still a lower, but it's for what it does. It's in its range. So you just hear that headline. It was in the headlines and everyone's talking about it. It was a buzz in the news for a bit. You hear that headline and then you're like, great, I'm going to use that because that's the best. That's what they say. I would say you have to stop for a second and actually put it in context, because in the case I was working with, there are actual limitations of, okay, well, I'm working with everyday hardware. So I couldn't load it on a local system that's a normal system, not like a dedicated system that had enough memory, that had enough computation time to actually execute that. So that was actually a very bad choice if I did that as a design. I would have to choose a model that's as small as possible, that's focused enough to get the job that I need done and fast enough. Those were the criteria. So when you look at it, you're like, wow, this model, well, if you were to compare the benchmarks according to what you see on the trends, this model is garbage compared to this one. Not necessarily, because in my case, it actually was ideal because of the size, because of what it was trained for and what the output was giving me. It was much better. And not only that, also the ease of use of working with it, with my tech stack, with like PyTorch and the Python tech stack was a lot easier. It was a lot less things to interact with. So understanding that just learning about things and actually doing it, you get two different results. So going back to these steps, remember, learn the stack, no hopping around. And then 3, build a simple MVP. The MVP means minimal viable product, minimal viable product, right? Basically, it works. It gets end to end. That means it's something that works. It gets you from the beginning to the end. The only thing about it, it's clunky. It doesn't have a quality of life things on there, right? It probably looks ugly. But the thing is not, you want to prove that the results work, right? And revolutionary AI that changes everything is not necessarily what you're trying to do. If you're trying to get customers, boring sells, right? Everyone has stacks of problems that are invisible to most of the world because they're not flashy enough. But that takes up most of the problems. If you could solve that, that's where the value is. Not the biggest home run ever, because that's what hits the headlines, and that's what's trends, is those big names, and that's what get people excited. But it's those everyday problems that you could solve that everyone always have, that makes you valuable and rare. Here's a tactical execution, basically a checklist of what you need to be doing. Step 1 is to audit yourself. Basically, I would say have a goal. Basically, figure out what the problem is and what the solution you're trying to look for. And to help you along, I would say use a SMART goal. And this is SMART. If you never heard of this before, this is an acronym that means specific, measurable, achievable, relevant, and time-bound. So when you make a goal, say a specific goal. Like, don't say, okay, I'm going to learn AI, right? You want to have something, okay, I want to basically solve for a restaurant their problem that right now they can't predict how much orders they need because they don't know how many customers are coming in, right? So if we're going to do a SMART goal where that want something specific, okay, you want to specifically to work with restaurants, something measurable. Okay, well, we have to have some type of metric. So let's say we want to increase how much, I'm going to make up numbers, I'm not in the industry, but let's say we want to increase the order by like 100, so the measurable is 100 more orders that we predicted, right? Achievable. Now, the thing is, I said 100. I'm not in the industry now. I do have worked with some startups or some people who are in the food industry who know this a lot better. They might look at this and you're saying, hey, that might be way too low or way too high given the actual criteria. So maybe put it down to, let's say, 50. Again, I'm making this up, but I'm just giving you something to understand how the SMART goal works. So 50 is achievable. 100, that's far-fetched. Or to give a more concrete example, let's say I want to get to the airport and I said I want to get there in 2 minutes, but the airport is a 1 hour drive away. That is not an achievable goal, right? So that's just to give an example of it. And something that's relevant. Does it actually matter to the business? Yes, in this case, for the restaurant example, it's relevant because they are losing money or they're getting angry customers because of the fact that they cannot predict their orders. They're not able to actually get their ingredients or get their inventory on time. So it actually affects their business. It's relevant. And time bound. How long you give yourself to actually achieve this? I could say in a month, right? So that's an example of like auditing yourself and making smart goals for this. And then the other thing is define your ideal user. So user meaning what is you're going to make your product for, or your AI engineer you're going to solve for. So if you're going to do, let's say you're going to try to work for a company, figure out what company that company does, what are their ideal user case or use cases for it, and make a model based off of that. And then the other thing is pick your AI focus, because AI is in every aspect, right? And you can't spread yourself too thin. Learn one thing and learn it well. Are you going to be specializing in computer vision, on looking at images and figuring out things? Are you going to be making like a recommender system, such as like what Netflix does, where maybe the company you're working for is something like Netflix, where they have, or a Shopify or something like that, and you're trying to figure out what people buy, and you want to make a recommender system what they should buy next based on their choices or past choices or what they browse at, right? That's another example. Or you might maybe for another company where you have a community with it, where they release a certain thing and they want to know how the community feels about it, a sentiment analysis tool or AI system. You can't sit down and read 1,000 different comments on hundreds of different platforms. You could have AI go through that and give you pretty much interpret that data and tell you, okay, people are generally happy about this product that we just released, or they're not happy, we have to pivot, right? The step 4, I would say, rule of 100. Now, I mentioned 100 just because it's a nice number people understand, in the metric system or System International, it's, base 10, so 100 sounds nice. But the main idea behind this is to have volume, is to keep doing repetition. Like, 100 days of coding is an example of that. 100 days of getting models, of getting data points. Actually, 100 is not a lot in most cases, but the main idea is it sounds nice, but it's mainly to do volume of that, right? And here, step 5 is the core loop first. And what I mean by the core loop, the simplest thing you want to make sure is you have data in, you have your input, basically input, right? And I'll just move this to the side. You have your input, and then your model in inference, meaning when it actually calculates, predicts, it processes the data. So process data right here. And then after that, you get your output. This is the simplest flow, your core loop you want to do first. You don't want fancy AI or fancy UIs or bells and whistles or everything look pretty or the greatest user experience or anything yet. You want to make sure your core works, and then you build on top of that. Because if your core doesn't work, nothing's going to work at the end of the day, right? And then finally, step 5, actually deploy something. Deploy it. You actually have to show something working. In fact, you lead with that. When you're discussing with customers or clients, you show the end result first to get them interested. Now they're paying attention. Then they're willing to listen to you. Then you become important. And again, important people get what they want. So show why you're important. Do something, deploy something, show them you can get them results. So here's the mindset that wins. One user, one problem. Hyper focus on that. Don't try to have this lofty goal and try to save the world or try to make the latest something that's better than the transformer model right now. AI engineers only feels impossible to people when you basically try to skip the part where you build for real humans. Basically, when you're trying to solve for a real problem, that's where the value comes in. So it feels impossible because when you look at it, you're just looking under the hood. When the end result, all you really want to do is, can you solve this problem? If you can solve this problem, it feeling impossible will go away, because now you could actually achieve what you set out to do, which is not necessarily learn everything you need to know about machine learning or AI or deep learning or anything like that. Is, can you solve a problem? And is this valuable? to people, and are people willing to come back to you for that solution, right? This leads into clarity over cleverness, right? I mentioned before, I worked with a lot of people who are PhDs, very, very smart, who are able to build models from scratch or think of ideas that nobody thought of right now. But the thing is, if you are trying to work with a client, you want clarity. Say like, hey, I could do this for you. This is your problem. And here's the ideal situation. Here's the solution that you want. And here's how my solution will get you there, right? You want clarity. That's what it is. Cleverness, they don't really care of how you built it, what's your tech stack behind there, how you plan to deploy it, maybe the details, stuff like that might be nice to know. The main idea is like, what can you do for me? You want to be clear about that, right? And with basically waiting equals quitting. Waiting, what I mean by now is that if you want to have results, act now on it, right? Because you basically have two options when you do it this way, right? Option A, you could do tutorials and pretend that you are learning for the sense of working in AI engineering. I'm sure you are learning things, right? But in the context of becoming an AI engineer and actually getting jobs related to this, or clients, or building an AI startup, or things like that, just learning without actually going and doing anything doesn't get you anywhere. You can have the greatest potential in the world, but if that doesn't get converted to kinetic energy, it's the same thing as doing nothing. That's why waiting is the same thing as quitting. The results are the same, right? The other thing is you could do is pick option B, pick one user, find one real problem. The best thing I would say is something in your own domain that you know really well, right? Find one user, one person, you identify a person who has a problem, right? Find their one problem, and then you figure out one approach of how to solve that problem, and then actually build a solution for them. Now you have confidence with it, and then confidence, comes from competence. Because you've done this before, you feel confident to go to other people, other users that have that same type of problem because you solved it before. And a lot of businesses just do that. And it's not necessarily AI. Just look at successful business that always have business year round. If you have a pool, for example, you live in a city that maybe certain times during the year, or maybe all the time during the year, but you have a pool. When pool season starts, you need someone. You could do it yourself, but a lot of people have someone to go and clean their pool and set it up and also close it, right? Though during that time, there are literally companies that all they do is just open pools for people and then maintain them and then close them. That's their whole business model. They figure out one user type or one profile. There's one problem they do, and they build their entire career, their whole livelihood on just solving that one problem because it's a recurring problem in that area. Now, if they try to do that same thing in some place like Alaska, well, they don't have that problem. They might have the skill, they might have the approach, but they can't find a single user without that problem. This is basic economics at this point, right? So that's the thing about becoming an AI engineer, is you have to bring in the aspect of what does the client want, how may bring in value, and how that's going to be an ROI for me, or else you're just learning, right? You are the one working on AI systems, and the things about that, you're just one AI system away from changing your entire trajectory. It's mentioned before that you could do everything wrong a million times, but as soon as you get that one success, that changes everything for you, right? The only thing stopping you between you and AI engineering is actually starting.